Welcome to the Microsoft IT Pro Podcast, a show about Office 365, Azure, and the IT Pro and end user side of life. Each week, we'll discuss a different topic or recent news related to Office 365 and Azure and how it relates to you as an IT Pro. The Microsoft IT Pro Podcast is never longer than 30 minutes, so let's get started. How are you doing today, Scott?
Oh, it is another beautiful day. Kids are back in school. The house is silent, and life is good.
At least until they come home.
There is that, and I still got the dog to contend with, but I'll make it work.
Sounds good. So school started today, right?
Oh, yeah.
Yay for first days back. None of my kids are old enough for school yet, so I still have the 3 that I had when we recorded the last podcast, plus the little baby that is now officially 9 days old.
Whew. Man, they get old fast.
Yeah, I know. Can't believe it. Next thing I know, they're going to be going to college. But no, I got my coffee. He's actually sleeping. He is, so far, are way more laid back than our first 3 were, which is good. We've been sleeping pretty well. My wife is very generous and lets me sleep, and she gets up during the night so that when the kids come running in at 7 a.m., I can shuffle them all downstairs and let her sleep for another 2 or 3 hours.
You've got a routine. It's a good thing.
It is. Well, and my mom's here too. She's helping out. Thankful for her. Otherwise,
full house.
Yes, we might not be doing this morning.
What are we doing this morning?
What are we doing this morning? I don't know. I'm trying to keep up with kids. No, this morning we decided, I decided I'd be nice to you this morning, Scott, and I would let you do 2 Azure episodes in a row.
Oh, man. What is the world coming to? Cats and dogs. They're all playing together. It's crazy.
I know. So this morning, at your suggestion, we decided we would talk about the Azure Application Gateway.
Yeah, so last episode we talked about some networking stuff with some of the new preview features for firewalls and SD-WAN, all that good kind of stuff. If you haven't listened yet, go back and check it out. But today we're going to talk a little bit more networking and get into one of Microsoft's ADC or Application Delivery Controller services, which is Azure Application Gateway. So the gateway, it's a little bit weird because there's just so much terminology going on out there in Azure land and Office 365 and every place else where we have, data gateways and we have app proxies and we've just got all this stuff floating around in relays and who knows what else. So the application gateway, it's a load balancer for web traffic. So we're talking specifically HTTP and HTTPS traffic and managing traffic to web applications that sit behind this load balancer. So if you think about a traditional load balancer, maybe something like Azure Load Balancer, like ALB, it's got internal and external flavors, all that good kind of stuff. That is a transport layer load balancer. So if you're thinking OSI model, that is OSI layer 4. And, they have some limitations. They're going to be really heavily round robin. They'll route traffic maybe based on source IP import to a destination IP import. Maybe they have some kind of settings for setting, like maybe like a 2, 3, or 5 tuple for doing some kind of affinity, but it's not really hard set the way it is. We're talking just TCP and UDP traffic layer 4 stuff in Azure Load Balancer. Sometimes you want to go further up the stack and have more functionality. We want to get closer to the client that's making the web request, and we want to have more control over the delivery of the application. So that's where we get into layer 7, OSI layer 7, or the application layer, like application presentation and session, technically, to get up that far, to deliver web applications to users. So that's where Azure Application Gateway, or the WAG, comes in, the Web Application Gateway. So you'll hear me refer to it as App Gateway, Application Gateway, the WAG, and then we'll talk about some other functionality and some other things. But anyway, the Application Gateway, like I said, it's a layer 7 application delivery controller, HTTP, HTTPS only. It supports session affinity, both cookie-based session affinity, or you can just do session affinity on your servers if your application's smart enough to handle it that way. It's got some really cool functionality built into it when it comes to things we would do maybe on other layer 7 load balancers that exist out in the world today, like software or hardware. So if you think about like F5s or Kemps or Barracudas, things like that. They'll have features like SSL termination or even like end-to-end SSL with encryption in the middle and some kind of logging. App Gateway does that too. It supports URL routing for unique routing of requests to various backend pools. So maybe you have like a dedicated set of servers in your application that serves images, and then another set that serves APIs, and another set that serves videos. And what you can do is based on the URL. So if it's like /images, go over to this set of servers. If it's /video, go here. If it's /API, go over here, and do these kinds of things. So that's all URL routing. Supports custom redirection, custom probes, and quite interestingly, also has a web application firewall or a WAF built into it as well. So we've got a WAG, which has a WAF and then does some other stuff on top of it. So that's kind of a high level intro. And then I figured we could talk about what some of the different components are and what goes into them. And then maybe where the application gateway kind of sits in a wider ecosystem.
All right. Sounds good. I'm excited to talk about this. I will be honest. It's been a long time since I've touched any of these devices. So it'll be education. It'll be fun to talk about this. So where do you want to start? What's the first aspect of it, I guess, that we should talk about?
Well, I think there's a couple things to get out of the way. You always hear me come in on these things and talk about like entitlements and pricing and all that kind of stuff. So let's kind of knock that one out, like what happens when you want to use the gateway and what's going on there. So from a pricing perspective, there's a couple things that happen. Gateways come in basically 5 SKUs today. So there's a small gateway, a medium gateway, and a large gateway. And there's some light guidance out there around things like throughput and how you might want to size a gateway to figure out the application you host behind it. So typically small gateways are going to be dev only. We'll never use those in any kind of like prod or upstream scenario. And then we get into kind of medium and large when we lock in some bigger things. So gateways have certain throughput. So something like a medium gateway with an average backend response of like a 6 kilobyte page, you'll be able to run like 13 megs of throughput, 13 megs a second through a medium gateway. A large gateway does 50 megs. And that's about as big as we can go today. But I said there were 5 SKUs, right? Small, medium, and large. That's only 3. What happens is that web application firewall that we're going to talk about, it's not available on every SKU. It's only available on the medium and large, and only when you specifically enable the WAF SKU to go ahead and turn that on. So technically there's like a small gateway, a medium gateway, a large gateway, and then there's a WAF medium and a WAF large. And what happens is the base gateway has basically just a charge per hour. So, go ahead and turn it on and it costs basically this much per hour, and do the number of hours in a month, and you'll get to the cost for, the region and data center that you're in, that you host out of. And then there's another charge that gets tacked on top of that if you decide to turn on the WAF or that application firewall to go ahead and turn things on. And then there's some data processing charges and some other things. But really what you need to do is, if you're going to, you go through all this and you get to the very end and you're like, wow, that sounds really cool, let's go use it. What is it? Well, keep in mind, you've got to pay for it. You've got to pick a size, and that features and functionality differ between SKUs, right? Whether we do medium large or WAF medium, WAF large, all that good kind of stuff.
Okay. So for the WAF, it's like a feature you enable. So it's not 2 separate devices. It's, hey, we're going to stand up this basic application gateway. And then for that medium and large, we just decide if, hey, we're going to check this checkbox and configure the WAF or not.
Pretty much. Yep. You'll check the checkbox, turn it on, and then you're all good to go.
And it looks like data processing too isn't necessarily inbound or outbound. Is it just the amount of data that flows through it in either direction? Because it looks like inbound and outbound inbound's free, outbound is standard data transfer rates, and then this data processing is so much per gig.
Correct. Yeah. So let's talk, and I think this will make a little bit more sense if we talk about what a gateway is. So at the end of the day, when you provision a gateway, you go, you know what, I really need, and I want to use this service. So say you pick a medium gateway. One of the first things you're going to have to do when you create that gateway, whether you create it through the portal or PowerShell, CLI, ARM template, whatever, doesn't matter, is you're going to have to figure out the subnet that the gateway joins. And so it's actually a service, a PaaS service that comes into your VNets, and it's going to join a subnet within it, and it's going to consume, and it's going to be the only thing that can live in that subnet. Because what happens is your gateway can scale from anything from 0 to 10 instances. So what you end up doing is effectively you're provisioning compute, or Microsoft's provisioning like managed compute on the back end. Okay. So if you think about like a VPN gateway, like pretty much you can think of that as like RDS on the back end, and like a bigger gateway has bigger compute behind it. Same kind of thing here. So really what we have is we have some managed compute on the back end. And when say I put a gateway on my WAG, an application gateway on my managed gateway subnet, and I go ahead and scale to 4 instances, well, I'm actually going to consume 4 IPs on that subnet, because technically there's 4 pieces of compute that are running in the background to get all my traffic in and out. So that compute costs money, which is part of your per gateway hour, but then you're going to have CPU spikes and other things, right, as traffic's coming through. So Microsoft's kind of smoothed all that out in just a data processing charge. So the amount of data that you pass through the gateway, you're going to be charged data processing for that, because it's consuming CPU and some other things. You're just not seeing it. It's been all smoothed out, because what happens is if I'm going to do a gateway, and say I do just an internal gateway and it's never exposed to the internet, well, I'm never going to have any inbound or outbound data transfer, right? My cost would be free. Yep. So if you think about it, having like really high scale compute for East-US 2 is like 7 cents per hour for a medium gateway. That's dirt cheap, right? So now they tack on data processing on top of that to kind of get it to where it needs to be. So where it makes sense, they can put the compute in and some other things. So it's a little weird as a customer, because you kind of come in and you have to go through planning, and you're like, well, what's my average page response size? Is it 2K? Is it 6K? Is it 8K? Is it a meg? Like, what am I pushing, application traffic wise? And then how much of that traffic is the gateway actually going to have to process? What is server to server? What's server to client? What's client to gateway? And it's a little esoteric, but you can kind of get there.
Yep. And it looks like data processing is still pretty cheap. It's like 0.7 cents or 0.8 cents per gig.
It's nothing.
Tiny fee. Unless you're shoving a ton of data.
Compared to standing up something like an MVA. So, if you're doing Kemps today or Barracudas, doesn't really matter what it is. Who cares? You're doing vendor X, Y, or Z today, and you stood up a network virtual appliance for them. You're going to be paying a ton of money, because you're paying for the baseline compute. It's on 24/7. You're paying for that cloud license, or the license for that actual thing to work. And then you've got to keep up with backend OS updates and just all the crap that comes with it. The nice thing about the WAG or Microsoft's Azure Application Gateway, fully managed service, there's no compute, there's never a server you log into. You just interact with it imperatively through PowerShell as CLI, declaratively through ARM templates, or just straight through the Azure portal.
Sounds good. Mover is a cloud migration company that specializes in moving your company's files from file servers or cloud storage like Box, Dropbox, and Google into Office 365. Their patented technology makes Mover the fastest OneDrive file migrator in the world. Moving dozens of terabytes of data a day is a breeze. Use Mover's free, industry-leading migration guides, or ask for a managed migration and they'll take the lead. With Mover, all your data is secure and intact. Running completely behind the scenes, you don't lose time, money, or hair while you transfer. Scan, plan, migrate, report. Migrations that don't suck with Mover. Visit mover.io for more info. So moving on, you had talked a little bit about some of the features too, like Session Affinity, which this one I do know, because in SharePoint land, Session Affinity can really change your interactions with SharePoint. So diving into Session Affinity, it looks like they have cookie-based Session Affinity in here. And For people that haven't used this, and again, I've used it with SharePoint, it's that ability to, because it's a load balancer, it's doing round robin stuff, and make sure that a user session stays on the same server. Again, so that once they hit server 1 behind this, they're always going to stay on server 1 until they're done with that session. Again, it just keeps them from hopping back and forth between sessions. Something like SharePoint, or I know a lot of other applications, when you start hopping back and forth between servers across the session, some weird things can happen. So I'm assuming this is one, too, that you can either enable or disable one of those features you have. SharePoint, I know they always said try to enable session affinity. Other applications, I'm sure it doesn't even matter. You can just turn it off, not leverage it at all.
Absolutely. You can kind of have your cake and eat it too here. And the really cool thing about session affinity within the WAG is it's a per backend pool setting. So if I have one set of servers in a backend pool, like say I'm doing that URL-based routing thing where maybe I've got like images and video on 2 different pools, maybe like, or APIs. Let's do like APIs and images. So images doesn't need session affinity, right? It's just delivering images. It's fine. So for that backend pool, I might disable affinity. But for my API pool, I might always want the end user to always hit the same server that's delivering the API. Maybe I do some managed caching or some other things in place. So yeah, what I can do is just enable this, per backend pool, and it's a gateway managed cookie. So because it's gateway managed, now I can start to do some interesting things with the servers on the back end too. Like this enables you to do things like connection draining. Say you want to take a server out of the rotation, you're going to want to like quiesce it first, right? And pull it out of the rotation. But if anybody's connected to it right away, you just don't want to kill their session in case they actually have to finish it up. So you can actually do connection draining and back them out nice and slow. And it's kind of just built into everything. So like I said, you just select that setting per backend pool and you're off and running.
All right. Sounds good. And then some other ones. So SSL termination, obviously a big deal in webland. Now, I would say you always want SSL. You don't ever want anything that's not SSL. Google punishes you now in SEO for not having SSL. This is another one where we can do end-to-end SSL with the gateway.
So you have 2 options here with SSL. You can do SSL termination. So basically, client comes to the gateway, and that's SSL encrypted. And then from the gateway to the backend pool, it could be port 80, port 8080, whatever weird port you need, right? As long as it's a TCP port to go ahead and go back. And then what happens is the gateway is doing all your encryption and decryption and passing things off. So you potentially avoid the overhead of that encryption and decryption over on your application. Now, I'm going to go out on a limb and say that the overhead for SSL encryption and decryption on a web server today, it's pretty negligible. So if you can, you should probably be doing end-to-end SSL, which the gateway absolutely supports as well. That being said, you might have an application that just can't run over SSL. Like maybe it's from a vendor and it only runs on port 80 and they don't actually, and it's got its own built-in web server or something else. Like maybe it's like a COTS application and it's just sitting on like an IaaS VM. What are you going to do? Well, I can still put SSL in front of it. I can still be fronted by the gateway and have that functionality and have all that come back. So absolutely supports loading your SSL certs to the gateway. You can share that cert across one or more listeners on the gateway, basically like one or more sets of ports. It supports things like SNI, server name identification, which is pretty important because your gateway only has one public IP or one private IP fronted on your gateways or on your VNet and subnet. So you've got to have a way to have potentially multiple applications delivered through one gateway because it's a PaaS service, right? We want to run that compute up as high as we can or scale that service up as high as we can. So we're not just paying for a bunch of them. Let's run it all through one and get better cost efficiencies and things like that. So it's kind of up to you for how you configure that one and what it looks like. You can absolutely like load self-sign certs in for testing. There's actually ways that you can even get the certs for like the cloudapp.azure.com and all that kind of stuff too through Let's Encrypt and whatever. So you can get pretty creative with that one. But you should absolutely have SSL on all your applications fronted, especially stuff to the internet.
Yeah, and it looks like this one, and I'm assuming maybe all these features are also that pool-based. So going back to your images and API example, you could even do HTTPS SSL when you're going to APIs and you might be passing keys back and forth and other data. And when you're doing images and you don't really care because it's just pulling an image out of a pool, you can do HTTP there?
Absolutely. So it is a per pool setting, and you get to kind of choose, you're really almost choosing an authentication mechanism, right? There has to be kind of a little handshake between the gateway and the backend server to be able to do SSL end to end. So that's just an option for you, is if you've got some kind of like maybe authentication certificate on the server side that's been loaded there, it could be the same cert, that doesn't necessarily matter, but just being able to kind of get it through and where it needs to be. So it is one of those kind of have your cake and eat it too things. And it's just a couple of checkboxes, are pretty easy to fire up with, again, PowerShell, CLI, whatever.
And then the next feature we have is that web application firewall. So this is the WAF that you can enable or disable on your app gateways. So what's all included with the web application firewall features?
There's a couple of things that are going on in the WAF. So when you turn it on, you can select from 2 rule sets and basically 2 sets of managed rules for OWASP rules. So if you're thinking about like trying to prevent like SQL injection or like OWASP top 10 attacks, things like that. And you can select today from the 2.2.9 or 3.0 rule set. And then you can potentially enable or disable specific rules within those rule sets as well. So say you want to do like OWASP 3.0, but you want to disable rule 91,018. I don't know why they named them that way and why they're numbered that way, but whatever. If you wanted to do that, you absolutely could to go ahead and push that through. And then the other cool thing is you can do with that WAF is you can run it in 2 modes. You can run it in detection mode or prevention mode. So detection mode is going to basically just flag and log the request. And it's going to say, hey, I saw this come through. Here's what it was. So you're going to have to turn on diagnostics and watch the logs and, maybe alert on it or things like that. And prevention mode will actually kill that request and shut it down. So if you're actively in the way and you're like, hey, I want to enable OWASP and I definitely want to prevent SQL injection, turn it on, put it in prevention mode, and disable all the rules you don't want, or heck, keep them all enabled. Like there's a default rule set. You can, again, go through and look at the rules and what they are. Pretty easy to get to.
Got it. And one nifty thing here, too, when you're doing your monitoring, it looks like they also have there's a WAF log, but this then integrates with all the other services, with the Security Center in Azure, with log analytics, event hubs. I think the storage tables in Azure. It integrates with all of those. So not only does it have like that WAF logging, but you can then shove it into all those other services in Azure, utilize all those other services in Azure to be able to bring those logs in with all the other logs to analyze them, look at what's going on across your entire environment.
Absolutely. And that logging is not just for the WAF, it's for the application gateway as a whole. So what you do is you would turn that on. Typically, we'll have baseline storage logging. So that's logging across 3 different logs, like an access log, a diagnostics log, and a health log. And it's just pumping those out as JSON files into Azure storage. Optionally, what you can also do, like you said, is stream that to other places. Maybe log analytics if you want to have some other type of retention, or you want to do kind of longer term reporting. And event hubs is an interesting one, because if I stream my event logs or my WAG logs to event hubs, that's how we integrate with other SIEM solutions. So say maybe you've got like Splunk or something on-prem and you're trying to run that information and get it through into Splunk. Awesome. Let's run it into event hubs. And then we've got a connector and we just fire everything through. And again, you can have your data wherever you want to have it.
I like that one too. And then URL routing. This one we've kind of touched on a little bit. I don't know that we ever went in depth on this, but this is a nifty one that we kind of alluded to with the API and the images. You can do this with images and videos, where you can now have server pools that one server pool serves up images, another server pool serves up videos, maybe another pool serves up audio. We'll go with the whole multimedia theme based on that URL. So whether it's like a /images/ and then your wildcard, same thing with video, you can route traffic to different server pools based on what the URL is.
Yeah, so that's it in a nutshell. It is super cool functionality because now you can actually have decomposed applications that sit behind the gateway. So, again, it doesn't have to be, I've got my whole application and it just sits in one big server pool. Maybe you want to have an application that's comprised of 3 or 4 server pools. Maybe it's 3 or 4 VM scale sets. Maybe it's actually like 2 VM scale sets, and then it's a set of IaaS servers. And then, oh, by the way, maybe even it's something like an Azure web app, like a PaaS service sitting on the side that's fronted by the gateway as well. So you can have all that stuff running through a single endpoint, and then the gateway is doing your monitoring, your routing, your logging, everything in the middle. And that's actually something I didn't mention about the gateway is it's not just for routing traffic to IaaS servers, and it's not just a load balancer for IaaS. It can point to any IP address or any fully qualified domain name as long as the gateway can talk to it. So it could even front on-prem applications as long as like your VNet's connected to your on-prem through a VPN gateway or maybe ExpressRoute, something like that. Or it can even talk to PaaS services. So say you had like an Azure web app that was sitting out on the side someplace, and maybe that's what's serving your images or whatever. Cool. Go ahead, run that out of PaaS, mix, match, do whatever you want to do to get your applications in place and have them be what you want them to be.
All right. So I'm trying to think when they say video here too. So in theory, I can't remember how Azure Media Service works. You can in theory then host your even videos like an Azure Media Service and route there to pull out your video. Maybe.
As long as it has a well-known URL and a well-known path, and the gateway can actually talk to that service for health and things like that. So you might need to implement some custom probes or some other things, but depending on the service and how it delivers the traffic, sure.
Nice. Yeah, that comes in really handy because, again, with Azure 2, when the way the VMs are with different sizes and what processing power or what service you may need behind the scenes to best serve up the various traffic, this really provides a huge advantage in being able to use the best service, use the best VM for the appropriate content it's serving back.
Absolutely. So I know we're getting kind of towards the end, but let's talk a little bit about where this fits in the ecosystem of load balancing stuff. So I mentioned there's the Azure Load Balancer, which is layer 4. Typically, you'll have ALB maybe in front of like clustered servers. Think like a database cluster. So I've got that always on availability group, always on availability listener, all those kinds of things. Well, I'll have ALB in front of that, and maybe I'll have the web application that sits in front of that, and then maybe that's got the WAG on it. So you can absolutely layer these things and combine them together. And then potentially maybe I want to put Traffic Manager and have like DNS load balancing in front of everything. So I can do, DNS load balancing, layer 7 load balancing, and layer 4, and have all the control that I need end to end and full stream, which is really kind of cool at the end of the day. So you have to, absolutely know your applications, know your workloads, what's going on, what you need to have happen, along the way. That part doesn't go away. But once you do, you can really start to kind of stitch and pull all these, sibling services together and stitch them together really nicely.
This is nice. I actually have an application I was working on with a client that we may go check this out. Like we've said before, there's so many services, it's so hard to keep track of what's out there and what you can use for all the various applications you may have.
That's about it, right? There's, 500 plus things. So here's another one, another tool in the toolbox.
Fun stuff. So one last thing, we have just found out, this will air in plenty of time, you and I are both going to be at Ignite again this year, doing the podcast, catching up on news, hopefully doing a live show.
Yeah, I'm looking forward to it very much.
I am too.
Although I got to figure out how to book a hotel. That's going to be interesting.
Yeah, that's the disadvantage of finding out this close to the conference of that we're going to go is finding a place to stay. Yeah, but that'll be fun. Well, if you want to keep up to date, hear more details, we'll talk about it on the podcast as it gets closer, dates, times, that type of stuff, or head over to our website, msclouditpropodcast.com, and you can sign up for the mailing list there. And there we'll, as Ignite gets closer to, we'll send out some information about where we'll be, when we'll be, where, all of that type of stuff, so you can get it right in your email.
Perfect. Thanks, Ben.
All right. Thanks, Scott. If you enjoyed the podcast, go leave us a 5-star rating in iTunes. It helps to get the word out so more IT pros can learn about Office 365 and Azure. If you have any questions you want us to address on the show or feedback about the show, feel free to reach out via our website, Twitter, or Facebook. Thanks again for listening and have a great day.